Autophagy plays a central role in preserving cellular health, yet one of the most unfortunate realities of aging is that this process itself begins to decline with time. As we grow older, autophagic activity slows down in nearly every tissue of the body, making it less efficient at clearing out damaged proteins, faulty mitochondria, and other cellular debris. This decline is not merely a side effect of aging, it is increasingly recognized as a driver of the aging process itself. When cells can no longer effectively self-clean, they become burdened with accumulated waste, which impairs their function and contributes to widespread tissue dysfunction. The consequences of diminished autophagy are far-reaching. In the brain, a decline in autophagy is strongly associated with neurodegenerative diseases such as Alzheimer's, Parkinson's, and Huntington's. These conditions are characterized by the buildup of toxic protein aggregates, which healthy autophagy pathways would typically help dismantle and recycle. When autophagy falters, the brain becomes less capable of managing this load, and neurons, some of the body's most energy-demanding and irreplaceable cells, begin to fail. This contributes to memory loss, cognitive decline, and mood disturbances, often seen with advanced age. Beyond the brain, the immune system also suffers when autophagy slows. Immune cells depend on autophagy to regulate inflammation, remove damaged intracellular components, and maintain energy balance under stress. When this regulation breaks down, the immune response becomes dysregulated. This can lead to both an increased vulnerability to infections and the onset of chronic, low-grade inflammation, a condition sometimes referred to as inflammaging. This persistent background inflammation is now known to be a common denominator in many age-related diseases, including atherosclerosis, diabetes, and cancer. Autophagy helps prevent these conditions by keeping the immune system efficient, balanced, and responsive. The skin, one of the most visibly aging organs, is another clear example of what happens when autophagy declines. Skin cells are regularly exposed to UV radiation, pollution, and oxidative stress, all of which damage proteins and cellular structures. In youth, active autophagy helps skin recover from this damage, maintaining elasticity, firmness, and an even tone. But as autophagic processes weaken with age, these repair mechanisms become sluggish, leading to visible signs of aging such as wrinkles, dryness, and uneven pigmentation. Fibroblasts, cells responsible for producing collagen, also suffer from accumulated damage, and this leads to the gradual thinning and sagging of the skin. One of the more subtle effects of reduced autophagy is the increase in cellular senescence. When cells accumulate too much damage and can no longer divide, they enter a senescent state, secreting inflammatory molecules that damage nearby tissues and contribute to age-related degeneration. Autophagy normally acts as a barrier to this process by helping cells repair themselves or, if beyond repair, guiding them to safe removal through programmed cell death. But as autophagy weakens, the number of senescent cells rises, creating a toxic cellular environment that accelerates tissue aging and functional decline. Despite these challenges, it is important to emphasize that the decline in autophagy is not irreversible. Lifestyle interventions have been shown to restore or enhance autophagic activity even in older individuals. Caloric restriction and intermittent fasting are especially powerful inducers of autophagy, likely because they mimic the metabolic stress signals that naturally trigger the cleanup response. Regular physical activity, particularly endurance and resistance training, also supports mitochondrial renewal and autophagic balance. Even sleep quality, stress management, and certain micronutrients such as zinc, magnesium, and polyphenol can positively influence the pathways that govern autophagy. This opens up a promising perspective. Although the body's natural autophagic rhythm slows with age, we are not helpless against it. Through intentional choices, it's possible to reignite these internal repair processes and slow the pace of aging from the inside out. Supporting autophagy as we age is not about halting time, but about helping the body preserve its natural ability to regenerate, detoxify, and adapt. It's a way of protecting the integrity of the cell, and by extension, the integrity of life itself.